So today we are just for almost 1 hour or something like that, we talking about CFD analysis, but the focus is outdoor airflow. Definitely when we say outdoor, it means wind involved, so wind driving airflow. Definitely this is not a CFD course because 1 hour is not enough, you know, to digging deep enough. Just we try to review applications and some case studies. Definitely more information available on our website, and also always I'm available to discuss or if you need additional information. So today we're talking about optimizing building efficiency. It is the webinar series. I think it's fourth. So we'll continue with different application, or depends on Direct's client feedback. We try to move in that direction. So we had recently question or people, engineers, architects reaching out, asking question about CFD ability of wind driving airflow analysis. So in this webinar, we focus how to use CFD improving building performance externally, and what's the limitation, what's the challenging, and what's the benefit. So yeah, my name is Shram. You can call me Sean. Having PhD in mechanical engineering with academic background, so director of Duratec. We will explain more here. Yeah, Duratec around 6 years in market, but after COVID, definitely more focus because 2000 established, but because of COVID, everyone affected. Also, we affected too. So, but after COVID, definitely we extend our ability, capability, and market. So now we are multiple engineers focus on developing mechanical services, focuses in ventilation and wind airflow, but we are growing very fast. But the main focus is help our client in their project with sustainability, safety, comfort, and definitely cost-effective design is very important when we are doing a job. So our approach is innovational, and every time we try to add value engineering to the projects. So it's variety. You can find more, in www.duratec.com.au. So, but let's focus on our webinar. So yeah, as I said, my name is Shram. You can call me Sean in Australia for easy pronounce. So I'm founder and director of Duratec, but before that, I worked for Lendlease Airco in Australia and some small companies in air conditioning and ventilation too. But before that, back to my mother country, Iran, I was assistant professor, academic background, more than 70 published paper and one published book, one in Springer English, mostly focus on water and pump industry, and also CFD. And in parallel, I work for a well-known company, Farab, and lead mechanical engineer and top manager. So, but moved to Australia in 2017. So, yeah, qualification is PhD, Master, and Master Mechanical Engineering, but focus on fluid mechanics, and mostly CFD. So all together gave me more than 20 years experience in CFD and mechanical engineering. So now this is the reason in projects that I'm leading the team. Our team brings academic background and industrial background experience. So I think is the best approach when you try to solve problem, because if you just focus on academic, is not applicable. If you just focus on, industrial experience, maybe is not innovative, or sometimes old school approach. So when you combine knowledge, academic knowledge, and industrial experience, is the best approach to help client in the project. And we try to do uh, iterative, and based on our customer feedback, we were successful. So let's focus on, wind driven airflow. Why wind driven airflow is matter and important? First of all is safety. Because the wind is useful, we can get energy, for example, wind turbine, or solve a lot of problem with wind, but also we have some challenges. Most of them is wind loading, AS 1170.2, so stress and some forces, especially for gust wind or a storm, is very important when we're dealing with a building, especially when building is very high rise, or is some, because now architects, they love to add unusual shapes in the design. And so AS 1170 point is pretty much for standard uh, buildings, cubic, or, so this is the reason now wind tunnel test or CFD can help. We will discuss about position of CFD and wind tunnel test later. So also facade and cladding problem. Again, wind drive can have some failure, or rain ingress, waterproof, and a lot of problem that we need to focus on, wind drive and airflow. Also, we talk about wind comfort and safety. So a lot of, balconies, terraces. Now Sydney's or Australia, the major cities, Melbourne and Brisbane or others, they looks like getting in New York, or Tokyo. So we need to prepare ourselves for this urban changing, because people want us to they live, or, children, they are in balconies. So we need to make sure they are safe, or at least comfort, in different wind. And also because Australia is coastline, so it's very windy. Health and comfort. So we talk about comfort. So also indoor, because of energy and, bills, I'm personally passionate about natural ventilation. So we want to use indoor natural ventilation to control the indoor air quality, rather than just count on mechanical ventilation, and that's costly. Reduce the risk of dampness, mold, and strategy is very important and very strict in NCC 2022, and will be more strict in NCC 2025. And one big solution is ventilation, and definitely is passive ventilation. We are not talking about forced ventilation, and wind is a key factor here. Improve outdoor wind comfort. We talk about it. Pedestrians, or balcony, or terraces, or whatever. So it's important when we're changing the urban environment using tower or whatever, we are changing wind direction or wind effect. So we need to consider. So again, here, wind tunnel and safety both are useful. We'll discuss later. Energy efficiency supports ventilation and cooling strategy. We talk about it. So reducing reliance on HVAC system, mechanical system, as far as we can, and optimize building orientation and lower placement. For example, architects is important to choose a good building orientation for solar or wind to decrease the uh, energy using, and relying on mechanical or electrical solution. Compliance and sustainability is important again because nowadays builders or developer they try to get Green Star certificate. So one of most important is using ventilation, natural ventilation, and wind loading or whatever external requirement properly. So and all we talk about is long term because a building is not building just working for a few months, is working maybe more than human, life cycle. So let's say 100 years. So we need to consider wind and also natural ventilation or outdoor or wind driving airflow for long-term periods. So this is the reason climate data is very important in our design, and it can be changed from one point or one zone to another zone. This is the reason it's important. Every project, every building, consider analysis, airflow analysis, doesn't matter wind tunnel or CFD, based on different location, building shapes, and a lot of factors. This is the reason AI uh, cannot, in my opinion, you can replace human with AI very soon for this matter because a lot of parameters and is different location to location. So you can't just use maybe we can generally or one estimate or initial, but in long term we can't. So yeah, for example, here is the wind loading data pressure, then structural engineer can use this pressure for facade design or structure design. And the goal is, reaching out this green star. But safety for people is most important. The following video shows from I think Euronews from Europe. Maybe you watched before, but it's worth it. Just we see here how changing urban design, using tower or whatever, and making wind tunnel. I mean, between buildings and how is important for we consider before developing buildings in our cities. Yeah, just I'm quiet and you can watch how just between buildings these people they are suffering just because of how design of this city speed of wind in this location. But if you can see it in just 10 meter or 20 meter farther, no wind. So if you can see from this zebra line, this turn line is hard to walk, but then everything is okay, or before is everything okay. But in this particular point, because of how city develop or that's area develop street. So also I am experienced when I'm going doctor in Castle Hill is everywhere knowing when I'm trying to cross through tower in Castle Hill. Again, I feel a lot of pressure, wind pressure from on my face, and you can see that when they designed the building, they didn't consider that. So yeah, this short video is available, it will be available in recording. So this is how important we consider wind. So I can categorize in four category. You can add more, but just I did this. With loading and cladding, we called already. So ensure facade and roof safety. Validate cladding design to AS 1170.2, especially when standard solution or DTS solution is not available. Identify local peak pressure zone. Sometimes we need to know particular, curve or shape or sharp corner, how effective. Definitely, again, wind tunnel and safety are useful, but both of them, they are limit and, challenges and beneficial. So we will discuss very short about that because we are not talking about wind tunnel test here. Wind comfort, so assess pedestrian wind conditions, safety and comfort. Manage discomfort area and try to give solutions. Sometimes you need to offer architect adding trees, more trees to stop the wind, or some maybe balustrade or uh, maybe glass screen, thick screen. A lot of solution we can find when we talk about the wind comfort. And yeah, also another solution is give feedback about building orientation from wind, because when you talk about wind building variation, a lot of parameters, for example, vision or solar, also involve and other factor. But from wind, we can say, okay, I did for Lendlease a lot, in this area. Air quality and dispersion, another factor. So, for example, in cities, we have a lot of commercial restaurant or toilets, or you have tower and a lot of heat, or pollutant pool, contaminant, they just pollutant just sprayed and exhaust to the atmosphere, but the atmosphere is not here, just empty space or field. It's city and people just living or driving or working. But this is important to consider, follow standard and sometimes no DTS solution. So we need to simulate and see is everything is according to ANSYS, but performance solution. So this is important. For example, how affect exhaust to intake. Sometimes you have intake for fan or something, and close by is exhaust from pool or from toilet or whatever is heat and also pollen. We are talking about both. So car park, kitchen, especially kitchen, because is can get people very strong. This is getting a strong illness, same as cancer. So this one also is very important, and we involved a lot of project to help our clients to make sure the project doesn't harm anyone. Natural ventilation. So as I said, this is important. As far as we can in Australia, we use natural ventilation. So it's for facade, roof, and also floor, and louver. A lot of applicable here. So, and safety can help to better choice or make sure we are in good track to use natural ventilation. So maybe what is safety? Just we review as a maybe someone watch or hear, doesn't know exactly what is CFD, but anyway, CFD is computational fluid dynamics, a method using numerical analysis that, you have numerical analysis in different fields, especially nowadays with virtual or, gaming is a numerical analysis because we are modeling real world in, just virtual world. So it's all categories same, but particular CFD, we are trying to solve fluid flow problems and optimize performance with computer. So we try to model, reality or sometimes a wind tunnel model in CFD virtually. So for CFD, we need three items important. First is hardware. You need to have computers and simulation. This one definitely 20 years ago when I started CFD, or 25 years ago, it was challenge, real challenge, because imagine Pentium, So I remember my computer burned multiple time because of, 2 days, one week, 2 weeks just simulating very simple CFD. Nowadays, my laptop is just 20 core. It means very powerful. Also, we have some cloud available, Amazon or Microsoft or Google, a lot available in market. So you can buy hourly or by core. So I can say definitely we don't have problem today about computer, hardware. Also, some new approaches, same as graphic or GP developing. So less dependency on CPU. But whatever is developing in this area, I mean, is not my concern anymore. Fluid flow problem. So you have computer, but what do you want to solve? So before that, you need to good software. Again, back to 20 years ago, just we talk about Fluent or something, very limits and a lot of problem, not accuracy or mesh problem. But nowadays, I can say most of commercial software, CFD software, they are in good position because a lot of user they use feedback, lot of validation behind that. So especially for wind that we are talking about, um, is that just single phase or sometimes just is two phases. I'm not talking about VOF model or solving two phase. I mean scalar array, just multi scalar or multi phase. So I can say most of softwares they are in good position to use. I have some comments about open source or free sources, but I don't mind, just put any brand down in this, webinar. But my general comment is that rely on commercial. I know it's costly, but because it has background support and developing, so you can trust more rather than open source softwares. So it's general comment, but I'm not saying that you can't use open form or, for example, FDS. No, you can use, but you need to be careful because they are free and limits. So when you want to use for a commercial project, you need to consider, okay, you are in this good position or not. But what we want to solve some equations. Yeah. So equation here is Navier-Stokes equations. Sometimes if we involve temperature is energy equation also added to Navier-Stokes simulation, or if you want to have mass flow, okay, you need to mass, equation also added. But normally we are just using, energy and Navier-Stokes equation. I don't want, to go about theoretical because very limit time. So what we looking for, to solve is definitely velocity. We know we want to see or we know about, especially when we call hot zone or very important zones that how flow and move, streamlines, velocity, definitely pressure and velocity they are linked because of Bernoulli equation. Or if we talk about simplify analysis, Euler or Bernoulli equations. Temperature, if we are considering temperature and heat is very important. Concentration, if we are talking about pollutants or, same as car park, CO2, kitchen also is important, how ppm, or for example, recently I'm doing an ice cream factory, ammonia leakage. So it's important how ppm, and they want to see how this ammonia leakage or when leakage happen traveling around the factory because safety and health problem for people or workers. Humidity is another factor when we're talking about outdoor airflow because we are real world, and especially in Sydney, humidity sometimes is hot, or Melbourne. Some areas opposite. Humidity is very low, same as Alice Spring or heart of Australia. So humidity also is a key, and we can talk more factors based on the projects we're talking about. For example, turbulence intensity or a lot of other factors can be put here. So just wrap up these slides. I can see that you need good hardware, you need good software, and you need good operator. No one just having knowledge about safety, or on other hand, being a mechanical engineer, knowing the phenomena can't do safety. You need both good knowledge about safety, good software, good hardware, and good experience about that topic. For example, if someone comes to me and said, can you do safety for a heart? Definitely I can. But if another safety engineer with medical background or biomechanical background can do, definitely the report he or she delivers is better than my report. So this is the reason Deratech is very, passionate in this area, because a lot of experience in wind and ventilation background. So also we have 25 years in safety. So combination of this knowledge and experience helps, our report is so practical. So this is important. So when you want to, because I have a lot of message or in LinkedIn or whatever, talking about, I want to learn safety. Okay, you can learn safety, just with one course, but you can't, give solution just knowing safety. You need to have experience both about physics, about that phenomena, for example, ventilation, and also safety. It takes time. You can't, capture this one just with one course. Anyway, let's move on to okay, how one CFD works. This is general, applicable for every CFD. I'm not talking about just, outdoor. You can indoor, talk about water, whatever, the same concept. So first is you talking about one design. It can be initial design, final design. So this design is I'm continuing anyway. I'm just because we are recording, so you can, any reason you can stay or you couldn't, join us, you can watch this presentation later. So benefit of safety of outdoor airflow modeling. Design available. Okay, we have design sometimes is deemed to satisfy, but deemed to satisfy is not optimal design, because whatever standard recommend is just general. They don't consider shape of building, occupancy, I don't know, location of project. So just general, approach. So in a lot of cases is not optimal design. So sometimes extensive solution. And we know that consultant companies, they design 70 or 80% of detailed design, and rest, supplier or contractor needs to design. And sometimes this design, is not updated or just copy and paste from other projects. So, we need to reconsider. So here we can help to minimize cost and also optimize this approach. So knowledge, experience, and qualification, I said, help to analysis this, design or redesign, whatever, redesign, but for example, safety engineer or redesign with someone. Car park is a very good example, or wind loading also. So then outcome can be deemed to satisfy again, or performance solution, alternative solution, cheaper solution, or sometimes verifying for detailed design, high performance, sustainable design. All of them is the target of safety analysis. You can ignore when you putting something on a report. Your report need to cover, help your customer cheaper solution, more sustainability, complying with codes. So all of them help them to have saving money, higher efficiency, and definitely sustainability. These three most items. So in along with complying with NCC, we are not talking about, because end of the day, you need to certify your, one engineer, verify the design complying with codes. So DTS with performance solution, this is generally again compare between what DTS. DTS is a pathway defined by the NCC. Key factor is fixed ventilation, for example, or wind or data. Straightforward, easy to apply, rely on compliance, but limited flexibility, may not suit unique, or sometimes you can't, practically do that because of limitation of projects. So here, performance solutions come customized approach using evidence to meet performance requirements. Key factor is, just we need to use tools like safety for analysis, and we need to show that okay, this approach is better or at least equal to DTS. Offer flexibility to optimize energy use, safety, comfort, whatever. Adaptable for complex and innovative projects. Must demonstrate, equivalent. I said so. Yeah, this table shows pros and cons of both of them. So here, normally we are using safety for performance solution or alternative approach. But sometimes also we need to show just DTS, maybe still we are following DTS, but maybe, decreasing cost or increasing efficiency to get green star. Still we are, staying DTS, but going farther than DTS. Anyway, so let's move on because we have 20 minutes. So just, this is again how you can define. So creating geometry is important. So you need to get more as possible, more accurate drawings or data parameters to create building model. Then safety modeling, run safety analysis, airflow pressure. But for that, we need good boundary conditions. So climate data, we need to rely on climate data, 30 years or 5 years, 10 years, whatever, based on that location, nearest, weather station. Also, we need to know the real initial condition, real project talking about. Geometry need to be simple as far as simplified, but not simplified, not considering reality, but balance between reality and simplify. Because if you use very detailed data, very detailed shape or geometry, you can't get good mesh. And poor mesh, it means less quality of the result. So this is balance between, how details your geometry and simplify. Then report and documentation report need to be short and comprehensive. Sometimes a lot of information in the report is not useful, so you need to choose the most important. Try to decrease the report. Sometimes I see reports 50 page and maybe 48 pages of that, just talking general. So now I prefer 10 pages report, but 70% is most important results talking, and just 3 pages introduction. So yeah, this is important to make your report very easy to understand, because no one is safety engineer when reading your report. So keep it simple, but not losing important parameters. No, we keep important and key data or key factors, but we prefer to short, easy to understand by user. Define project requirement. So to do that, we need to define project requirement. For example, what we need, what's the goal, because reports need to cover that end of the day. So report needs to back to the start, what we needed, what was the goal, what was the target. So this is how this loop, works. And sometimes we need to optimize again or analysis again, changes or based on client comments or based on our. This is the reason safety engineer need to have experience in that field, because when you see result, yeah, oh, maybe it's reliable safety or not, because you have experience, you have sense. But if you don't have, you are just junior engineer or even maybe senior engineer, but not this field, so you can't judge the safety result is reliable. Maybe mistake happen. This is the reason you can't trust uh, every CFT report. This is I'm very very strong uh, argument in this area. When, for example, some person, that engineer or that company can do cheaper. Yes, but they are using junior engineer. I'm not saying junior engineer is not valuable. I'm saying that a report done by experienced CFT engineer in that field is more valuable, and you can trust reliable than an engineer with less CFT uh, experience or experience in, for example, wind or ventilation area. So you can compare, two CFTs, not saying that one software, just this is input and output, and just this is report. No, we can't. You need to involve to make sure your approach is, optimized or best approach. So some case studies, for example, this is the wall cladding pressure equalization factor. So the challenge is that the question is, okay, we have one pressure in front, facade, facade face or surface. What is in cavity, the pressure? Because they want to see this, they call backband displayed pressure. But if we use, normally they are using 100%, so you need thicker material. But with this approach and CFD, we show that the average is 70% of, for example, if is the surface pressure is 2 kilopascal, you need 1.4 for design of area. So the metal thickness decreased from 0.9 millimeter to 7.7 millimeter. Okay, 0.2 millimeters is maybe nothing from, just initial view, but imagine one big tower, I don't know, hospital, very big building, and a lot, I don't know, maybe imagine just vertical is 40 meter, 50 meter, and then around is around, I don't know, 1 kilometer, 500 meter, and how many, different in cost and also installation, because lighter material. So this is how just simple CFD, but very practical, very, niche area, helped my client to save for a hospital project in New South Wales. So how we calculated, we model very simple, but 3D. And then we try to model the gap, cavity gap, apply boundary conditions, and then simulating for different wind, maybe 4-8 direction, and then finding the average weight of pressure, and then, okay, the result almost 70%, and it's helped the project a lot. Another case study is for residential dome house in New South Wales again, because maybe in Middle East, or you can find a lot of dome, but in Australia we don't have. So standard 1170 or AS 4055, talking about just cubic or rectangular or simple shapes. Again, architects, they love to add unusual shape to their design because they are artists. So here safety can help. Also wind tunnel can help, but wind tunnel is expensive. Wind tunnel can't give you this lovely picture, visual things you can see. Optimizing is not easy because when you change your geometry, again, you need to do everything from first, but in safety is easy. So for low and medium, safety is definitely recommended, independent of wind tunnel, but for high rise, maybe safety can decrease wind tunnel cost. So for high rise, I recommend safety and wind tunnel, but mid rise less than 100 meter, pretty sure you can trust and the wind tunnel. Or sorry, just here anyway, we use again bundle layer. Sorry, why is that happening? Velocity profile to apply for a train. Is it based on train in that New South Wales area? We model for 8 direction or 16 directions of wind, and we capture the surface pressure. We consider 2 scenarios. One, door opens, so internal pressure is not 0 negative, it's positive, and maybe from other side negative. So we consider different, maybe 32 scenarios. And also we had ULS and SLS conditions. So it's very big safety for just this dome. This dome is maybe sport, is a bowl and cap. So it's very special. It's not long. It's 10 meter or 15 meter high house, but because of unusual shapes, the structural engineer wanted to know the pressure, wind pressure on uh, this area or back or front of this cap, or what we call that, this balcony, and I forgot. So this is important, and safety helped a lot, and we gave to structural engineer a lot of data in different, and they used their own, I don't know, Pythoning or whatever, to convert this pressure to force for timber structure they are using here. Another one is one lovely client. They want to see their new wind product in markets is rely on VBA, Melbourne building, code. So we compare for them for VBA recommendation building. This is what's the standard method, and this is their method. So we compare both safety again for different wind direction and different wind speed, and the result we have here, you can see that okay, it's for different wind speed. This is VBA recommendation. It's their approach definitely is higher ventilation airflow rate, and this cross is for Melbourne. So we can see definitely their approach is better than DTS or VBA recommendation. this safety analysis again help them to show their client or government, practitioner or whatever, to show that their product works well and better than usual or conventional vendor approaches. So just if we can wrap up this webinar. So why wind is important? Because of safety, comfort, ventilation, and energy use. Safety helps simulate real wind flow to guide better design decisions. Application cover wind loading and facade pressure, same as this. Outdoor wind comfort, we talk about it. Passive ventilation, especially for roof or louver, floor or facade, cavity. For mild or, moisture control, and a lot. Air quality is another problem in our cities now because of commercial kitchens or, pollen from toilets or pool, a lot. So it's heat and pollution, both is problem. So outdoor airflow or wind-driven airflow can affect positively or negatively. So we need to consider with safety. Better outcomes, we can safety support, to, architect or mechanical or wind engineers to optimize their project to comply with NCC and also sustainability and, well-being, because buildings, we're talking about, people, and people are most important, in the world. So we need to look after them, and safety can help. Real world impact, design issue resolve early through simulation before going, for example, you can with, I don't know, 5K, 10K or something like that to pay safety, to make sure your design is good rather than you involving, on-site measurement and it's late when you spend a lot of money. So you need now spend maybe 100K to, redesign or change your design when you build it. So safety can help to save money and help, to decrease your mistakes in your projects. So feel free to review more case studies here. We can jump, our website. Our website, we have a lot of solutions you can review about building, safety analysis, a lot. Also, we have different projects, but most important area is resources. You can find in this area a lot of case study, we added, and we will add more because, as I said, Dialectic strength point is innovation, and this innovation or this approach came from academic and experience background. So we're trying to add monthly or weekly something here. So you can see we have a lot about safety, but talking about our webinar topic, we have wind loading design for rooftop. We will review now. Cases to optimization, ventilation. We have how safety optimize building roof and wall cavity, condensation risk, safety analysis of wind loading. We already reviewed that. Wind loading approach, natural ventilation, again here, 1170. You can see a lot. You can find case studies, and always feel free to reach out with this information, design@duratech.com.au or phone number. So all here, just shortly, maybe in 2 minutes, I can just review, for example, this project we did for our client for Weipa, Queensland. Very humid, so they use HVAC system or AC system. We choose temperature zone, rooftop package for them because the project is in Weipa, very humidity, 100% humidity, is north in Australia. So not Queensland, but I mean the position is north of Australia. So what happened? Yeah. So just shortly, we simulated, again for wind, 207 kilometer per hour is very high wind. Imagine a car, driving your car with this 207 kilometers, So it's very high pressure. So we calculate the pressure and then applied to the structure to see the structure, here is enough to carry this wind or not. So this is one application of safety. If we back to our source, for example, this is ventilation. So for example, this is a plant room in Parramatta. So we have a transformer here. So they relied, or the design was with fan mechanical ventilation, but they approached us. We designed for them fully ventilation, 100% natural ventilation using Luba. So again, we consider, different wind direction and wind approach and complying with related standard. The standard is, where is the standard? The standard is not, here, MCI 006 for electrical standard anyway for transformer. So this is how, again, CFD helps, to comply with standard. So again, here you can find more and more approaches about general safety and also safety applications, and in particular for our webinar, outdoor or wind driving airflow. So yeah, any question? So again, feel free to reach out for any inquiry or further discussion. Our general email is design@duratec.com.au. This is phone number, this is website, and also feel free to follow us on LinkedIn. So I'm just stopping recording, and feel free to ask question if you have. So just what is that? Stop recording. Yeah, and thank you for everyone watching, later for recording, and thank you very much for. I will update this on YouTube so you can watch every time when you are free. Thank you very much.